everyone. Exercise number 10 is going to be a little bit different from the ones that we have been solving before. They ask us to find a formula, find an equation, a written function, a linear function way, if I may. And they give us a bracket, f of x, and the first equation in the bracket is 0 if x is negative, and x if x is positive. 0 if x is less greater than 0, and x if it's greater than 0. So let's draw this in our xy axis just to have a better visual understanding of the problem. So we draw our xy with a little ruler really quick. Here we go. We have x-axis and y-axis. And now we're going to plot the function f of x and the two elements in the bracket of the equation. First, orange, 0 if x is negative, which is the orange line I just drew right here. Next, x if x is positive, which is this part of the equation. So there we go. We have the two graphical representations of the bracket of f of x. So y equals 0 is the negative portion, and y equals x is the positive portion. Each one is a different portion of the bracket. Now, 0 we can rewrite as x minus x also. And y equal x, well, there's pretty much no other way to write it other than y equals x, because that's how we have it in the bracket. So why do I have it written into two ways? Well, because most likely anything related to a bracket has to do with absolute value. And absolute value, as you may have recalled, is a definition of function that can be defined as a bracket. Absolute value is x for x greater than 0 and minus x for x less greater than 0. Why do I say all this? Because this is a problem in which we have to think. There's no real actual procedure to solve the question that is being asked, other than that, the fact that we have to come up with a way to solve f of x, to come up with the function f of x. So if we were to do this, then if x minus x represents the negative part and x the positive part, maybe we can do a little bit of a trial and error with f of x equals x plus absolute value of x and see how that solves, because we have the positive part written by the x part, but we also have the absolute value that is going to help us with the bracketing portion that we have in the initial part of the problem. So let's rewrite that proposal. Let's just brainstorm and see if that solution may work. If we rewrite the function, then we're going to have x plus x if x is positive, and minus x plus x if x is negative. And if we rearrange this, where we rewrite it again in a more simplified manner, we're going to have 2x if x is positive and x minus x, 0 if x is negative. So if we compare this with the initial problem, you see that they were on the money on the 0 portion, but we're off when it comes to the 2x portion, because we have 2x instead of x. We have 0 if x is negative. That's good, but the 2 is bothering us. So what do we do to get rid of the 2? Well, if we were to somehow apply a factor of 1/2 and get rid of that 2, somehow that would be, pretty much the solution that we would be looking for. So let's turn the sheet and see what happens if we write the same plot, the same formula, the same equation, but with a 1/2 factor. So f of x is going to be equal to 1/2 that multiplies x plus absolute value of x. And that would be your solution, right? That would be our potential solution, our probable solution for the problem. So let's break it up and see if it works. F of x is going to be equal to bracket, and then we're going to have 1/2 multiplies x plus positive x if x is greater than 0, and 1/2 that multiplies x minus x if x is less than 0 or it's negative. And as you can see right here, if we do the arithmetical part, rewrite the bracket portion of the function, then we're going to have, well, x plus x is 2x, which means 1/2 that multiplies 2x if x is greater than 0. And then at the bottom, we're going to have 1/2 that multiplies x minus x 0 if x is less than 0. So as you can see, we can simplify the 2's, and we can simplify 0 times 1/2 is going to be 0, and we can rewrite this. Therefore, the bracket is going to be x if x is greater than 0, and 0 if x is less than 0. And as you can see, this right here is the original problem, which means we were able to solve by brainstorming. As you can see, there we go. We have the original exercise solution, and we were able to break it up by doing trial and error on absolute value. See you on the next exercise.